So, okay, so let's start from where we left off. I hear that some of you are not able to follow or were not able to follow last time a few of the things. So I will start from the, not start from the scratch. I will not do the whole thing, but we'll break. It will help also. More you see things, okay, it reinforces the concept. There's nothing bad, but I will not take the full evening, okay, on the same thing. We'll spend 15 minutes and then we'll build some questions. So last time we talked about what? Can some of you tell what are 3 things we discussed last time? 3 important things. We talked about bars and stars, right? And what is bars and stars? Any kind of problem where you can arrange a certain number of things. For example, you know, you have x1 plus x2 plus like that, okay? And xk minus 1 plus xk. What does it mean? It means, think of it like a, you have this many boxes, right? This is box number 1, this is box number 2, and you have box number 3, okay? Sorry, box number k minus 1, okay? And the last box, box k. Now we have some fruits being put into the boxes, okay? And we want that all of the boxes, if they're counted, the fruits are counted inside the box, they should add up to a certain value of n. So think of it, okay? If k is equal to, say, 3, okay, and n is equal to, say, 8, then what happens? We have x1 plus x2 plus x3. Remember, k equal to 3. That means there are 3 boxes now, right? 1, 2, 2, 3 is equal to n equal to 8. Listen. Right? We are telling x1 plus x2 plus x3 equal to 8. Now, 2 things come. Are we allowed to have a box which has no fruits? So the whole thing that I'm asking is that if we are not allowed to have any boxes with 0 number of fruits, then we are telling that it should be something like 1, 1, okay, 6, or maybe 2, 3, 3, or 3, 3, 2. Remember, 2, 3, 3 is different from 3, 3, 2. Okay, this is something we told, right? These are not same. 2, 3, 3 is not same as 3, 3, 2 for the simple reason in 2, 3, 3, the box number 1 has 2 fruits and box number 2 has 3 fruits. On the other hand, here it is box number 1 has 3 fruit and box number 2 has 3 fruits. Okay, these are not same. These are different. Now, the question is that if we are not allowed to have 0 fruits, then we are essentially telling x1, x2, and x3, these are all variables. These are all greater than 0. Okay, these are some integers. These are integers. Okay, these are not fraction, right? However, all of them are greater than 0. And then we told that if this is the scenario, what we do is you have 8 here, and I want some help here. If there are 8 fruits, what do? Can one of you guide me and help me understand, okay, how it should be done? If this is what I'm asking you to solve, x1 plus x2 plus x3 is equal to 8, with x1, x2, and x3 greater than 0, how many ways can we arrange the fruits in this 3 basket? Anyone? No one? You didn't?
I think so, like, to represent each fruit, you would draw out 8 lines.
Okay, so we have 8 fruits, so we're drawing 8 lines.
Yeah. 1, 2.
Yes.
And then in total we have like 3 different kinds of fruits. So to represent like the 3 different separations of the fruits that have to equal 8, we would put 2 plus signs like in those spaces. So to choose where those plus signs would just be like 1, 2, 5, 6, 7. It would just be 7, choose 2.
So we are basically telling out of these 7 gaps that you have, like, no, these are all the eligible gaps, right? These are all the eligible gaps, whatever I'm giving. Eligible means we can put it in anywhere, right? So if we choose one of them or two of them, right, in this scenario, so let's say we choose this one and we choose this one, okay, right? Then what happens is that this is another way of telling, right? These gaps are the walls, okay? It is 3 because we have 3, 1, and then 3 and 2. If you put this plus sign here, right? If you put the plus sign here, okay? See, this is 3, this is 3, and this is 2. If you put the plus sign here, okay, and you put another one here, say, okay, then what happens? Then what happens is this. These 2, right? You have 2, then you have here 3, and then you have 3, right? And all of them add to 8. So that means the problem now reduces to how many ways can you place 2 bars, right? 2 bars, because we have 3 kinds of fruits or 3 baskets, right? So how many ways can you put two plus signs or these 2 dividers, right? Divider because they're dividing it into multiple baskets in 7 available spot. And why 7? Because you have 8 total count, this 8 count, right? This is at 8 counts, and there are 7 gaps in between. As long as you can place them, it would be good. And remember, if you even place it here, right, then also you have 1 fruit. We know that it should be all greater than 0, right? You cannot place the divider here because it doesn't make sense, right? There will be no fruit at all. So you have to place the divider or the plus sign in between the sticks. So this kind of problem is called bars and stars. Bars and stars, these are the bars, okay? And instead of plus sign, generally what people use is that they use the dividers with stars, okay? This is what we do, okay? And we tell that, okay, this is another way of looking at the problem. All of you good with this one, this approach?
Yeah.
Okay. Now, again, the problem is same now. Now we are telling x1 plus x2 plus x3, okay, is equal to 8. But I tell you that what would happen if x1, x2, x3, these are all integers. And integers means we generally write in a fancy way, okay, like this, okay. But z means integer, okay. Remember, this z means integers, okay. And what does this mean? This means belongs to, okay. You're basically telling each of these values, x1, x2, and x3, each of these variables, they belongs to integer group, okay. And with that, we can, the question is that why do you use all these symbols, okay? This question always comes, right? The reason why mathematicians like symbols is because otherwise we have to write a lot of things, right? x1, x2, x3 are integers. We do not want to write too much. Mathematicians are generally lazy people, okay? Very lazy, okay? They do not have time to write unnecessary things, and they write symbols, okay? That's why we use this symbol. This symbol means belongs to. Belongs to means, no, they belong to a particular group. And which group? Integer group. Now, that being said, I'm also telling that they cannot be 0. That means they're integers, but they can be 0, okay? So we are telling they could be 0 or any positive integer, right? So that means this is equal to, right? It could be 0 or greater than 0. So that being said, 0, 0, 8 could be a solution now, because 0 plus 8 is equal to 8. So this is a solution. Remember, last time we did not allow the 0 zeros, right? We told that it cannot be 0 here. And now we are telling 0 is allowed. So if this is the situation, how many ways can we have the set x1, x2, x3 equal to 8? Right? So 0, 0, 8, okay, could be 0, 0, 8, okay, could be one of the solutions, or it could be 1, 7, 0, or it could be 1, 6, 1, because all of them are adding to 8. All of these are solutions, and I'm asking you how many solutions are there. Remember, 0, 0, 8 is different from 8, 0, 0. That means what I'm telling is that these are actually different solutions. Do not treat them, okay, 0, 0, 8. Here also you have 8, 0, and 0. Then there's one and same. No, they are not same. They are different, because in the first case, the x1 is equal to 0, x2 equal to 0, and x3 equal to 8. Here, x1 is equal to 8, x2 equal to 0, and x3 equal to 0. These are two different solutions. Now I'm asking, how many ways can you arrange the 8 different items in 3 boxes such that each box can have 0 or more items? Anyone wants to give a try? Silence. No one got it last time?
Oh.
If you want to get x1, x2, and x3, okay, let's define 3 variables. Now, let me help you understand what we mean by that. Think of it, at any given point of time, if x1, x2, and x3 satisfies the solution, okay, then we can always define another set of variable, okay, variable means y1, y2, and y3. Think of it like this. x1 maps to y1, x2 maps to y2, and x3 maps to y3. What does it mean? That means for every x1, we have some y1. Now, how is y1 defined? We are telling this set, right? This set, we're calling x set, and this is y set. So we are telling every single element, x1 plus 1 is equal to y1. x2 plus 1 is equal to y2, plus 1 equal to y3. This is something you can understand from practical life itself, right? If I have, okay, if I have a group of boys, okay, and I give different number of, different number of, say, sweets to all of you, sweets, and like, no, and so there are n number of boys, okay, n number of boys, and b for boys, and these are the girls. We have exactly same number of girls. I'm telling G1, G2, and Gn, and each of the boys gets, say first boy gets B1 number of sweets, this get B2 number of sweets, and there's Bn number of sweets, and girls get G1 number of sweets, G2 number of sweets, and Gn number of sweets. Now, if I ask you, right, okay, that every single boy, okay, gets one more than the every single girl. So we can tell, okay, fine, maybe B1 or maybe the G1 is getting one more than the boy, right? That means we can tell that the relationship between the boys and the girls, okay, boys set and the girls set, okay, can be represented like boys plus 1 is equal to girls. That means essentially I'm telling every element in the boys set, okay, plus 1 is equal to every mapped element in the girls set. You understand what I'm talking? This is called mapping, okay? Because there is a relationship between the boys and girls across the element. That does not mean that every girl is getting same number of sweets. That also does not mean the boys are getting the same number of sweets. All I'm telling is that for every single boy, there is one girl who has got exactly one more than that boy. And this is true for all the elements, okay? That's all I'm telling. For every single boy, there is one girl who has got one more than that, and one only, not more, right? So I'm telling if the boy has got 2, then there is 1, 3, okay? Yes, there could be another 2, okay, another 3, that's fine. But it cannot be, we have 2, 3, and then this boy is also mapping to this, okay? It cannot happen. This is called one-to-many mapping, okay? One-to-many, because one boy is mapped to many girls. That's not what we're telling. We are telling 1-to-1 mapping, okay? 1-to-1 mapping. So this is what exactly is going on. So I'm defining 3 variables, y1, y2, and y3, such that x1 plus 1 is equal to y1, x2 plus 1 is equal to y2, and x3 plus 1 equal to y3. That's fine. If we do that, then x1 plus x2 plus x3 becomes what? If x1 plus 1 equal to y1, right?
y1 plus y2 plus y3 plus 3.
y1 minus 1. Remember, x1 plus 1 equal to y1.
Minus 3.
Yeah, there is a deliberate reason I give plus 1. You might ask why I'm doing it. Because we know x1, x2, and x3 could be 0, right? I do not want them to be 0. I want them to be at least 1 more, okay? So if it is 0, for example, this guy, okay, I want this to be mapped to 1, 1, and 9. Right? This one should be map 2. Map 2 means 1 would be mapping to 2, 7 would be mapping to 8, and 0 would be mapping to 1. 1 would be mapping to 2, 6 would be mapping to 7, and 1 would be mapping to 2. So now the problem reduces to y1 minus 1 plus y2 minus 1 plus y3 minus 1, okay, is equal to 8. In other words, y1 plus y2 plus y3 is equal to 8. And this negative 1, negative 1, negative 1, they go to the right-hand side, it becomes plus 3, that is equal to 11. But now we know that these variables that we introduced, y1, y2, and y3, each of them cannot be 0, right? Because if it is 0 indeed, if x1 is 0, right, then y1 is at least 1, right? So we know that none of them can be zeros. And we know how to solve this problem. We did it just now. So in this case, the problem reduces to, right, 11 minus 1, right? Because 11 is the total number of bars you have. Just remember whatever we did last time here, right? In this previous, you have number of sticks, right? This is equal to n, right? That is the number of bars. So the problem reduces to 11 bars, okay? So 11 bars means there are 10 gaps, 11 minus 1 gaps, right? 11 between the bars. Out of that, we have to choose how many kinds? There are 3 kinds, so we have to choose 2 stars out of that, okay, or 2 spaces out of it, right, where we'll be placing the stars. So 11 minus 1 and 3 minus 1, 3, because we have 3 kinds, so it'd be 1 less than that. We saw that, right? So the answer would be 10C2. So last time the answer came out to be 8 minus 1, right? 8 was the total, and C 3 minus 1. So 7, choose 2. In this scenario, what we get is 10, choose 2. Okay, choose function. Happy? This is what we did last time. Now, that being said, we move to something which we call as partitioning. Now, what is partitioning? In the partitioning, what we try to do is how, oh no, sorry, we did not talk about partitioning. My bad. Let me take back. Okay, we did not talk much about partitioning. We'll talk about it today. We talked about derangement problem last time. What is derangement? Derangement, I give a very classic example where there are, say, 4 postmen, okay, 4 post boxes. So we have house number 1. Okay, let me show it to you. So we have, say, house number 1, house number 1, house number 2, house number 3, and house number 4. I want to send letters to these 4 houses such that none of the houses gets the letter to which it is really meant for. That means house number 1 will get a letter either from house number 2 or house number 3 or house number 4, like that. And I want to say how many ways can we deliver the letters so that none of the houses gets the letter which it is meant for. Now, this is a very complicated problem. I deliberately want you to go there because you can think of a lot of things happening out here. Today, we'll do that once again, but in a little bit different way, so that we can do it together, a little bit interactive way, and let me see whether I can help you to understand, okay? So first of all, let's try to ask ourselves if this is indeed the scenario, and if there is no constraint means there is nothing like that, okay, that house will get their own letter or not get their own letter. These are not constraints, okay? How many ways can you think would be delivering the letter? I would name the letters as 1, 2, 3, and 4. In an ideal scenario, house 1 should go to house 1, 2 should go to house 2, 3 should go to house 3, and 4 should go to house 4. How many ways can you deliver the letters if there is no constraint? Anyone? How many ways can you deliver the letters? Okay, 1, 2, 3, and 4 to houses H1, H2, H3, and H4, such that there is no such that. Okay, how many ways?
4
factorial.
4 factorial ways.
4 factorial ways, which is 24, right?
24, yeah.
24, right? So let's write down these 24 cases, okay? And let's do it together. So, and if you have a notebook, you can do it yourself also. I do not care much. Okay, but this is what I'm doing essentially. I'm telling, write this 1, 2, 3, 4. Okay, this is one of the cases. Then I'm telling, okay, 1, okay, 1, 2, 4, 3. Okay. Then I'm telling 1, 2, sorry, not 1, 2 now. 2. Okay, 1, 3, so 1, 3, and 2, 4. And then I'm telling 1, 3, 4, 2, right? And then I'm telling 1, 4, okay, 2, 3, 1, 4, 3, 2, right? Then I'm telling 2.
So uncle, just so like even while you're like manually writing everything, while doing it orderly, you're basically still doing what like the derangement formula says, just like a more manual way. Like you're setting the first letter, then you start with setting the second letter, and you set all the letters until you get to 4. But that's what basically the derangement theorem is stating, right, uncle? That you set one letter and then you rearrange the, like, how many ways can you rearrange the rest? Like you multiply them and you add all the combinations.
What does it mean? I'm not getting what you're trying to portray.
So, uncle, you're basically first, like when you're manually writing it, you start with 1, right, as the first digit. For how many ways can you write it, uncle? Even like then you're setting the first letter and then calculating the amount of ways you can, or like you're manually
That's okay.
calculating.
No, the reason I'm doing it is deliberately I'm going in the long route. Okay, and because I will today by the end of the class you'll understand. Okay, why I am insisting and not even I'm telling that. Okay, fine. No, it is needed. I'm not giving option. Okay, I want everybody to understand the manual part very well. Of course, we last time we derived it. Okay, I have a sense that none of you, those who even claim that they understood, I think you have understood. I'm having a kind of sense that you did not get it fully. Okay, why it is happening? You got it overall maybe 80%, for some of you 90%, but none of you got it 100%. And I'd be very clear. Okay, you'll come to know why I am making this statement, because I'll give you one problem which is somewhat similar to whatever I'm stating now. Okay, but I will change the nature of the problem, and then I will test, okay, each of you. If one of you can answer it confidently, that question, then I will tell you have understood everything. But for the time being, let me be a little bit of skeptical that you are not understanding. Okay, and let's do it together once. Okay, there is no harm in it, because more you do and understand the depth of it, okay, it concept becomes clear and you'll be able to tackle the problem. And I do not, okay, want, again, I told it so many times, I'm repeating it once again, I do not like this idea of no derangement formula. None of you, please stop it. Okay, at least in this math circle, please stop it. You talk about your formula and theorem in your schools. Okay, you are most welcome. In my in these sessions, I will not allow anybody to use any formula. As long as I am here, no formula, because formula is what kills mathematics. Okay, and this is I'm very strict about. I'm only one thing I'm strict about. Okay, is not to use formula, because remember, okay, I've told it many times to many of you. I insist it on once again, okay? The competitive examinations are being crafted in such a way, okay, that none of the student, okay, has an unfair or in a disadvantageous position because one of them knows a formula and another does not know the formula. That's not the whole idea. If somebody is teaching this, they're teaching it wrong, okay? That's not the whole idea of this examination. They want every single competitor, okay, to be in an equally advantageous position. That means they would craft the question in such a way that even if somebody does not know the formula but knows the concept, okay, they can derive the formula on a fly and move through. You understand what I'm talking about? There's a difference. Okay, so if one of your friends know the formula and you do not know the formula, they do not want that person who knows the formula to apply it quickly and move forward and attempt a question and get a higher marks than you. That's not the whole idea of mathematics. That's being taught in schools and taught in a wrong way. I tell it confidently. Okay, they will not move forward at all. Okay, the whole idea is that all the students should be in the same position. Then how are they differentiating? If you understand the concept, even if you forget the formula, don't know the formula, that's absolutely fine. But if you have to know the concept very well, the algorithm is important. Okay, and if you want to know the algorithm, you have to be a little bit patient. Okay, you have to work in a little bit tabulated way, but it is worth the patience that you are showing. Okay, or the diligence that you need to solve a problem. I hope you're getting my point, right? Please do not use any formula. In fact, that's why I desist from telling things like NCR is equal to factorial n factorial r n minus r. You see that I generally do not do that. Every time I tell you, I ask you that why are you using this? Let it be in your head, break into your head. Please do not use any kind of formation, okay? Formula. Because that's a very bad and practice. Can we do that together? Yes? All of you?
Yeah.
Okay, good.
Yeah.
Okay, then the mathematics is fun. Otherwise, mathematics become a bunch of formula, and at some time we all get bored. Okay, I do not want any of you to get into that zone. Okay, some formula we are putting and substituting. Please do not do that. Okay, so let's do it together. Okay, and see what happens. And sorry about it, I got off track because of this. And I will show you, why I'm insisting. We'll just realize, just be a little bit patient, okay? Maybe 10 minutes, okay? And then we'll be done with this. So now we are continuing this, okay? So 1, 2, 3, 4. Then we have 2, 1. Sorry. 2, 1, 3, 4. 2, 1, 4, 3. 2, 3, 1, 4. Remember what I'm doing between these two. If you really observe very carefully what I'm doing, it is in a very orderly way. I'm replacing 1 and 2, right? Here 1 and 2 are getting replaced. So look at this, 1 and 2's position have swapped, right? So it is 1 first and then followed by 2. Here 2, 1. Here 1 was in the first position and 2 here. Here 2 is in the first position, 1 is in the third position. See, I'm doing a little bit orderly way. You see that, right? All of you. And then what I do is that I also tell 2, 3, 4, 1, because 1 and 2 I'm swapping. Okay, 2, 4, 1, 3, 2, 4, 3, 1. Okay, and then what I do is that 1, 2 is done. Then I now go for swapping 1, 3. Okay, 1, 3. If I swap, then it will be I start with this only. Then I tell 3, 3, 2, 1, 4, right? 1, 3, 2, 4, 1, then 3, 1, 2, 4, then 3, 1, 4, 2, then 3, 4, 2, 1, and 3, 4, 1, 2. Okay, and then finally I swap 1 and 4. So we have 4, 2. Look at this, 1 and 4 are getting swapped. 4, 2, 3, 1, and then 4, 2, 1, and 3. 4, 3, 2, 1. Then we have 4, 3, 1, 2. And then we have 4, 1, 2, 3, and 4, 1, 3, 2. Anything I've missed? Absolutely no. You see that there are 6 here, then 6 here, then 6 here, and 6 here, right? This 24 cases is the way you can arrange among them yourself, right? Means all the letters, okay, can be arranged or sent to the houses in this order. So what effectively each of these elements represent? These represent that house number 1 got its own letter, house number 2 got second letter, house number 3 got third letter, house number 4 got fourth letter, right? And similarly, this represents house number 3 got house number 1 got third letter, house number 2 got second letter, house number 3 got first letter, and house number 4 got fourth letter. Okay, all of you with me? All of you? Any question on this arrangement? Pretty simple, right? So far, good. All of you?
Yeah.
Okay. Also, This letters, let's number it, okay? Number it because of my convenience, okay? I'll tell you why I'm numbering it. So let's number this like this, okay? I'm writing this as number 1 arrangement. This is number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, number 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. Okay. Now what I do is that I tell you, okay, to solve this problem, and our original problem is the derangement problem. None of the houses should get the letter which they are delivered. Okay. So in order to tackle this problem, what I do is that we tell there are 24 ways. Okay. There are 24 ways, which is nothing but your 4 factorial, right? Or 24. Okay. 24 ways we can arrange among themselves. So of course we have to take away any of the cases, okay, where at least one of the houses have got a letter to which it was addressed to. That means if somebody gets a house, okay, if one of the houses gets its own letter, right, we should not be taking that particular arrangement into our consideration. All of you are with me. If any one house, at least one house, okay, in these 4 houses, at least one house have got a letter, okay, which it was addressed to, then it should not be a part of the solution. Don't you think so? Right now we have 24, right? Cardinality of this set is 24. When I'm telling cardinality of this set is 24, what I mean is that think of it, this is one element, right? This entire group. This is one more element. This is another element, okay? Think it like this. Okay. So I'm telling right now we have 24 cases. Out of these 24 cases, we have to reject or we have to subtract all the cases where at least one houses have got a letter which it was addressed to. All of you are with me?
Yep.
Yeah.
Yeah, uncle.
Yes. Now I want one of you to tell me what should be the strategy. Any of you can take the lead now. And Manu, you also can take the lead because you are there if you want, or any one of you. I want to know how you're thinking. Yeah, go ahead. Sorry.
So should I like explain it with like mathematically, or should I just explain it like logically, like how I would just think of it?
Yeah, think. Let me hear how you're thinking.
I'm just looking at like the first number to see if it's a 1, second number see if it's a 2, third number see if it's a 3, or the fourth number see if it's like a 4, and then I just eliminate it.
Okay, so good idea, right? Is it who is talking now? Ritik?
No, Arjun.
Arjun, I'm not able to see. I'm so sorry. Okay, I don't know who is talking. Okay, all voice seem so similar. Okay, thank you, Arjun. So your point is that you want to eliminate all the cases, okay, where you see one house. So let's start with house number 1. Is it a good idea? Let's start with house number 1. Anywhere, if the house number 1 is getting the letter number 1, right, then those cases has to be eliminated. Do you all agree?
Yeah.
Anywhere, the house number, any of these, I'll go through all the elements. Anywhere I find that house number 1 is getting letter number 1, those cases should not be in our consideration.
Right.
Right. So let's do that first, okay, and see, and I'll put it in a set, okay. We know how to write the set, right? So look at the first one. Do you think it should be eliminated? First one.
Yeah.
First one is number 1 which I've circled. Yes, right, because the 1 has got is 1, okay, and therefore it should be eliminated. So I'm writing 1. No, it should be eliminated. Then do you think this one should be eliminated? This one? Yes, because again, house number 1 has got the 1 letter, right? Which should be eliminated. Third one also, yes. And I continue. If any doubt, let me know. 4th should be eliminated. 5th should be eliminated. 6th also should be eliminated, right? Up till this. Should this be eliminated?
Yeah.
Why?
Because 3 is in the third
so
spot.
we'll come to 3 later. Let's focus our attention only on house number 1 now. Okay, we'll talk about house number 2 in a minute. Okay, let's focus our attention only on house number 1. If you just look at house number 1, you do not care about 2, 3, and 4, okay, at this stage, okay? We'll talk about it in a minute, okay? So, but if you only focus on house number 1, then it looks like, okay, only these 6 are into consideration, isn't it?
Yeah.
Any other houses? No. So that's fine. Okay, 6. Now you're telling, let's focus our attention to number 2. Now if I tell, okay, fine, just you're focusing on house number 2. You do not know what has happened to house number 1, house number 3, and house number 4. Then what are the things that you are going to eliminate? Again, start from the first one. Are you going to eliminate house number 1? Yeah, sorry, the element number 1?
Yeah.
Yes, absolutely. Because now here all 2 has got its 2. So you're telling, please eliminate 1 again. 1 means this one I'm circling means the first element. Okay. Are you going to eliminate number 2?
Yes.
Yeah.
Also. Number 3? Just
No.
focus on house number 2.
No.
Please do not focus on anything.
No.
No. House number 4?
No.
No.
5?
No.
No.
6?
No. No.
No.
Number 7?
No.
No.
Oh,
No.
8?
No.
No.
9, no. 10,
No.
no.
10. No. 11.
11, no. 12, no. 13?
Yes.
13.
Yeah.
Very good. Then 14?
no.
Yes.
Wait,
Yeah.
yeah.
15?
No.
Yeah.
16?
15.
4.
17? No. 18? 19?
Yes.
Yes.
And 20. Yes.
20, yes. Then 21, no.
21, 22, 23, and 24 are all no.
No, it's very
No.
good. So look at this. Just because of house number 1, when you knew, you eliminated 7 cases. Do you agree? These are the house number 1's cases. House number 2, again, see that. Okay. It's still 6 again, but for a different reason, right? You eliminated this because of the house number 2. Do you all agree?
Yep.
Yeah.
Now let's go for house number 3. Okay, see what happens. Let's do it. I know that a little bit, this is very, very boring, okay, but I want you to feel a little bit bored, okay? Because once you get into your head, then you can explain to anybody. This is a complex thing you're doing. Now let's go to house number 3. House number 3, okay, so number 1, is it true or not? House number 3 getting its 3rd letter. Is it true? Applies here?
Yeah.
Yes.
Yeah.
It should be eliminated, right?
Mhm.
Would you eliminate number 2?
No.
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 3?
No.
No.
So tell me, which one is the next? I do not want to go through the whole process.
Next one is 6.
Next one would be house number 7.
6th or 7th?
Oh, no, my bad. Yeah, house number 6.
6 gone. Then 7,
Then 7.
And
Gone.
12.
then
12.
7. Then we have 12. Okay, yes, 12 gone. What
And
else?
then 19.
19.
19 gone. Very good.
24.
And 24.
So again, how many got removed? Again, 6.
6.
It should be the same amount with
And-
4 as well.
The
You
amount
remove
is same,
four.
but it's not the same. No,
Yeah.
it does not have any order, right? We'll see. Okay, what's going on here in a minute. And then what is the last one?
Yeah.
So first one you should eliminate is 1.
4. Okay, 1 is of course yes.
1, 3,
7. 9.
7, 9, 13, 15.
And then 19, 20, 21, 22, 20. Oh, wait, no.
Yeah.
Did you correct? I did not check also. I just went. 1 is correct. 3
No,
is
you're right. You're
correct.
right.
7 is correct, and then 9 is correct. Yes, 13 is also correct, and 14 is not correct. 15, right? 15 is correct, and nothing else. I think. Yeah, that's it. Because we have 6 again, right?
Yeah.
Yeah.
Okay. So now it looks like we have to eliminate this 24. Okay. But do you see a problem now? We are eliminating 1. Okay, we are duplicating, right? Are you seeing this 1 is here, but 1 is here in the for the second. When you thought about the second house, you also got 1 removed, right? 3rd house also got 1. So you are removing some of the overcounting, right? You are removing a little bit more than what you actually need. Do you all agree?
Yeah.
Yeah.
Now let's try to think about it in another way. Why did it come to 6? Okay, how did you get this 6 times 4 equal to 24? The reason is this. You thought, okay, house number 1 is getting its own slot, right? and you do not care about what happened to 2, 3, and 4. So you are trying to arrange 2, 3, and 4, which are 3 different houses and their letters, okay, in 3 factorial ways. Do you all agree? House number 1, you are fixing. Fix means you are fix. Fix means you know that house number 1 got its own letter, and you do not know what happened to 2, 3, and 4. They may or may not have received. So we are telling, hey, why don't you arrange, okay, 2, 3, and 4, okay, in 6 ways. Do you all agree?
Yeah.
That means you got that 6 because of that only, right? But then you went to house number 2. You again told that, okay, fine, 2 is getting its own letter. Let's fix that. Then we are left with house number 1, 3, and 4, okay? And let's try to arrange the letters among these 3 houses, and therefore again have 6, right? Because 3 factorial. So effectively what you did in this whole process is this: 24 minus, you are selecting one of the houses, means from the 4 houses, you are selecting one house, that is 4C one ways. And then because you have selected the house which got its own letter, you multiplied by the rest of the 3 houses in 3 factorial ways. That means 4 times 6, which is 24. And that's what we are seeing in this count. All of you are with me?
Yeah.
Okay. If you're with me, now the important thing is coming is that, sorry, okay. Now what we are seeing is that we have developed, but then we see the problem in hand. The problem begins because we are seeing 1 we double counted, right? 2 also we double counted, isn't it?
Yeah. Some of the numbers repeat.
Repeats. So now we have to, we cannot do double counted, so we have to give it back. So we do this subtraction, whatever we did, okay, this value is a little bit more than what we should have done. So what we thought, now our thinking is that this number, okay, represents the number of ways at least one of the houses got its own letter, but we do not know what happened to the other houses. That means it is quite possible that some of them, okay, has 2 houses receiving their own letter, right? That is not taken into consideration. So those are overcounting. So what I'm going to do is that now we are going to check, okay, how many of the cases 2 houses, okay, got their own letters, okay? Because 2 houses, if they're getting their own letter, that is a subset of 1 house is getting their own letter, right? At least 1 house getting own letter. So if you're having at least 1, that also includes, okay, at least 2. So what I'm going to do is that, okay, now let's try to add or give back, okay, give me a little slow, let me go here. So now let's try to find out what are those cases where we have at least 2 of the houses getting their own letter. Let's go through the whole process again. So let's fix this, no, these 2 houses. Say A and B are getting their own letter. We do not know about C and D. Does one fall into that criteria where A and B house are getting their desired letter?
Yeah.
So that means it has to be given back now to the pool. Do you all agree?
Yeah.
Because look at this. No, here 1 was true, but 2 was also 1 in the 1. Okay, 2 is also getting its own thing, right? So here both of them are succeeding, right? So I have to give it back because that is a little bit of overcounting it's contributing to. So I'm now giving back, okay, the 1. Okay, what else? Where else do we have A and B getting their own? Even here.
2.
2. What else? Is there any places where
7.
That should be it.
From 1 to 6, Uncle?
6? No, 6 is not, right?
No,
No, it's
I'm asking from 1 to 6 I think those are the only ones.
Only
I
ones. There's
those
no
are
other
the
places.
two in- Yeah.
That is A and B, right? Now let's think of A and C. That means 1 and 3, okay, in their desired position. What are the
3 and 4.
1.
1?
Yeah, 1. 3.
Oh, yeah.
No, 1.
Oh, no,
2. No, 1.
1 and 6.
1 and 6.
6. Yeah.
Very good. Now A and C, then now A and D.
1 and 3.
3. 1 and 3.
And
That's it.
that's it, right? Very good.
Yeah.
So 1, 3, 2, 4. Yeah, correct. So now it's done. Now A and D. Okay. Now B and C.
1,
B and C. B and C means 1, of course, yes.
and then so B and C, right?
19.
Yeah, 19.
1,
That's it.
B and C. That means B and C means we need 2 and 3, right?
2 and 3.
19.
So 1 and
Yes,
19.
right.
Yeah, that should be it.
And then B and D.
1,
1.
1, and 2 and 4. So it should be 1 and 13.
2 and 4, 13. 13 is correct. And then C and D.
And Sandy should be 1 and 7.
Good job.
Yeah.
And that's all we can have, right? So how many you got? 1, 2, 3, 4, 5, 6, 7, 8,
12.
9, 10, 12, right? Now let's see, okay, how did we get this 12, okay, in another way. So I told you that 2 houses, okay, should get the letter what they deserve or what they are expected to get. So you
how many ways
ask
can we
yourself,
choose
how
2?
many ways can I get choose these 2 houses out of 4 houses? You tell 4, choose 2. Are you with me?
Yeah.
And you do not
Yeah.
know what happened to the other 2 houses. They may or may not have got their own letter, right? So
So
that
how-
should be arranged in 2 factorial ways. Right? What is the value? 4 choose 2 is?
6.
6 times 2 is 12. And those are the 12 elements, right? Do you all get the point?
Right.
But now,
Wait,
when you
sorry.
did that, yeah.
Can you repeat that part like one more
Yeah,
time?
so what I'm telling is that, what was the question? Question is that how many ways, at least, okay, at least 2 houses have got their own letter. That's what we are trying to find out. So let's try to choose those 2 houses out of 4 houses. So 4 choose 2 is the number of ways you can choose 2 houses out of 4 houses. All of you are with me?
Yeah.
And then once you choose these 2 houses, the other 2 houses which have not chosen, they will get some letter. Now they either get their own letter or not get letter, okay, do not know. So that means they can arrange, right, among themselves. Arrange means arrange the letters among themselves, okay, not arrange among themselves, arrange the letters among themselves. So can I tell that would be in 2 factorial ways?
Yeah.
And that's exactly what happened. Look at it. That's what you exactly do it, right? Once you are fixing that 1 and 2, okay, other who are arranging among themselves, right? So this should be the total number of ways, and that means 4 choose 2 is 6, and 2 factorial is 2. There should be 12 ways, and if you count it, you will get 12, right? Are you getting the point now?
Yeah.
Not sure. Should I go back?
Uncle, this resembles pi a little bit, right, Uncle?
Not resembles. It's pi only, but
It is pi. Yeah, it is pi.
I want you to understand. Okay, look at it here. So here, when you're choosing 1 and 2, right? Look at it, what happened. What was the idea? Idea was that A and B are fixed. Fixed means A and B are getting their own letters, right? If A and B are fixed, that means you know that A has got his own letter, which is 1. B has got its own letter, which was 2. Now, 3, either it will be 3, 4, or it will be 4, 3. Do you agree? And that's what has happened. 3, 4 or 4, 3, which is our number 1 element and number 2 element.
Yeah.
Right? So that's how you chose 2. Now we are telling, say A and C are fixed, not A and B are fixed. So if A and C are fixed, then you know that, okay, 1 and where is that number? Okay, 1 is there. Yeah, 1 and 3 are fixed, right? Now you're telling either it will be 2, 4 or it would be 4, 2, right? These 2 spots can be arranging among themselves. Got it? That means essentially you are telling, first tell me which are the 2 houses which are fixed. Well, there are 4 houses and you want to fix 2 houses, right? And when I'm telling fix means the houses are receiving the letters to which they are addressed to. And you are telling that, okay, it would be 4 choose 2, which is 6. Now, when the houses are fixed, the houses which are unfixed or not fixed, okay, their letters can be arranging among themselves. And that is in 2 factorial ways, right? And therefore, it would be 4 choose 2 times 2 factorial. Does it make sense by product rule?
Yeah, it makes sense.
Yeah.
Okay, so that's why we get 12, right? And we are seeing that it's indeed 12. Okay, that's where 2, 2, 2, 2, 2, 2, and that's 12. But now again, there is a problem, right? Once you give it back this plus sign, now we are seeing that 1 is getting still repeated, right? And so is 3 is getting repeated, because at least 2 includes at least 3 as well. Don't you see so? At least 2 means when I'm telling A and B are fixed, A and B are getting their houses letters, okay? That also includes the cases where A, B, and C are getting their letters, right? When I'm telling A and B, at least A and B are getting letters, then you can tell, well, it also includes all those cases where A, B, and C are getting the letters. That means I have again given a little bit too much, right? I have to subtract it. So what I'm now going to do is that I'm trying to find out where at the 3 houses, at least 3 houses have got their own letter. And how I'm going to find it out? Let's fix those 3 houses. What are the 3 houses? So let's say A, B, and C. So let's try to find out how many cases all A, B, and C got their own letters. Say first one, does it qualify for that? For A is getting own letter, B is getting its letter, and C is getting its own letter.
Yeah.
It is, right? Is there any other places you are seeing it? Is there any other places you are seeing 1, 2, 3? For A, B, and C are getting their own letters. I do not know about D.
It's just
No, just
Oh,
that.
absolutely
It's
one, right?
impossible.
Next question is that how many ways A, B, and D are getting their own letters?
1,
And what is that?
number 1.
Number 2. Wait,
A, B, and D are getting their own letter.
It's
Yeah.
only
It will be again 1 only.
Only number 1. Yeah.
yeah,
Yes.
1.
Because there's no one spot, right? We are almost now end of the problem. Okay. Now B, C, and D, again 1. Right?
Yeah.
If you're C, D, and A, again 1. So how many times you would have the 1? How
4.
many ways can you fix the spot? Okay. So it is out of 4 houses. If we fix 3, that means 4 choose 3, right? It will be
Right.
4 choose 3. Now we are
Right.
getting the pattern. It should be plus. Sorry, it is plus, and now we are subtracting again. So 4 choose 3. These 3 houses are fixed, right? And only 1 house is left behind. That is 1 factorial. Do you get the point? What I'm talking about?
Yeah, I think so.
Yeah.
Okay. So now it is entirely clear what is going on. That means, and that's the end, right? Because 1 house, nothing is left now. Now we have got the entire range. So answer would be start with 4 factorial. Okay. Or you can tell 4 choose 0. We are not choosing any house initially. There is no houses to choose. Everything is arranging. And then I'm telling 4 choose 1 times 3 factorial plus 4 choose 2 times 2 factorial minus 4 choose 3 times 1 factorial. And that's the answer. Are you getting this point?
Uncle,
Yeah.
just one more time I'm asking, why don't we add the 1, Uncle? At like the 4 choose 4.
If you have chosen the 3, 1, okay, now what are you left? You have already seen it. Okay, tell me. Okay, yeah, last one. What is
Like,
the
why
1?
not what?
Now,
Yeah,
I'm
why?
telling 1, 1, 1, right? Now what do you do? What will you do? If 1, 1, 1, what was the idea? Idea was that you choose 3 houses. Now what are you going to add here?
Like, that's for the 3, Uncle. What about the one where all 4 go to the same spot?
You're telling this guy?
Yeah, like all 4. I mean, it's only one way you can do that. 1, 2, 3, 4.
Well,
But
I mean, when you multiply by 0 factorial, it basically just goes away.
yeah, but you still have to count the 1, right?
Yeah.
But tell me, what does this element signify? I want
Like 1, 2, 3, 4. Like all houses go to the same spot.
so why you
Or
started?
all
What does it?
cards.
You started with, then didn't you start with that? What does it mean? It means nothing.
Mm-hmm.
You see, that's what in mathematics you have to ask yourself. Do not go by the pattern. I understand pattern is important, okay, but you have to tell, okay, fine, what am I doing? I am telling that first I started with all 4 houses, okay. I arranged completely randomly, right, across, and then there are 24 ways. But in the process, we understand that when we have 24 ways, we have there are a lot of houses which are getting their own letters. Therefore, we are telling subtract, okay, possible houses, okay, which are getting at least one letter delivered to their house. I do not know about the other three, okay? And therefore, we tell how many ways can I choose one house out of the 4 houses, and that is 4 choose 1. How many houses am I left behind? It is 3. How many ways can we have these 3 houses deliver the letters? Okay, one house I have fixed it, okay, in 4 ways, right? And rest of the 3 houses can have their letters arranged among themselves in 3 factorial ways, which is equal to 6. So we have 4 times 6, which is 24. Once it is done, we have a problem, because we are now seeing that we did a little bit of over calculating or over reduction, right? We reduced a little bit too much. We saw that problem, right? House number 1 was getting too many times, 2 now 2 is getting too many times. Because when I'm telling at least one house got their own letter delivered, it also includes all the scenarios where at least 2 houses got their own letters delivered, right? So we now started adding. So we have plus 4 choose 2. Okay, how many ways can we fix 2 houses? It is 4 choose 2, and then 2 factorial. And then we tell 4 choose 3. Then we fix 3 houses. Now, if choose 3 houses, isn't the process stopping now? Because 3 houses means 1 house you are not choosing, right?
Yeah, no, that makes sense.
And that's all you can get, because 3 houses, look at this. If you know this 4 choose 3, then the last house is guaranteed to get. And that's what we saw. 1 1 1 1 was coming, right? Because nothing is there now. Now that set is 1 1 1. That means we know now guaranteed this is the first case, okay? Initial case, okay, has come. What else can you do? So this is the most random. Think of it. This is the most random, and this is the least random. Why I'm telling least most random, because these are all the possible arrangement, and this is the least thing that you can do. Not sure? Not
No, that makes sense.
okay. So this is the right way of permuting, okay, or doing the things, okay. So that being said, all of you got a sense of it. I want you to try it out the way I depicted it today. Have you got a sense of it now? What's going on?
Yeah, I got it.
Okay, fantastic. Okay, now I ask you another question. Okay, an interesting question. And here's the question. Okay, what's the time now? 8:34. We have half an hour. That's fine. So the question that I'm asking now is that, think in a desert. Okay, I took the problem from a book. Okay, one of the books that I love. Okay, but I want you to hear the question first. Think of there are 4, not 4. Should I go for 4? Maybe 5 is also fine. Okay, 4 is also 5. I'll go for 5 maybe. Not 4, maybe 4. A little bit of problematic. It's not problematic. Actually, you can do it. There are 4 camels. Okay. 1, 2, 4, 2, 3, 4 camels. Okay. I'm telling that this is camel A, camel B, camel C, camel D. Or maybe I'll give one more camel. It really doesn't matter. I will want you to generalize it. 5 camels, okay, in a desert. They're moving in a caravan. You know how they move in a desert, right? B is following A. They're moving in this direction. So B is following A, C is following B, D is following C, and E is following D. All of you are with me? You understand what's going on? Hello?
Yeah.
Now what happens is that these caravans, because B is following A, okay, B got really bored, okay, and C is also bored. They're telling we are so tired, right? Following, seeing the same camel, okay, every day, okay, we are following, going in they're tied by a rope, okay. So they tell, okay, fine, why don't we arrange among ourselves, okay, a little bit, okay, with one condition. We do not want to follow the same person whom we are not following before. That's the only thing they tell you. we do not want to follow, okay, the same person or same camel, right, in this scenario, as we are following before. That means B is ready to follow anyone other than A. Right? A was of course not following anything, so A does not have doesn't matter. A can follow anybody because A was not following anybody initially. C's only constraint is that C does not want to follow B, but anything else is fine. D is telling I do not want to follow C, and E is telling I do not want to follow D. Have you got the problem?
Yeah.
I'm asking how to do it. Okay. And before you go to and tackle, see, problems becomes interesting when it's like a puzzle. Okay, do not treat it as mathematics. Okay, then it's no fun. Okay, I am okay how you do it. Okay, you can count. Okay, write down all the different possible arrangement. I do not care as long as you have an algorithm. Okay, like the way we did last time, you're doing good mathematics. Okay, I'll give you another problem. I'll throw the problem because that way you understand what I'm looking for. Now, say another problem I'm giving where there are 5 kids when I'm in a merry-go-round. Merry-go-round. In the merry-go-round, what is happening is that 1, 2, 3, 4, and 5. And the merry-go-round is going like, say, anti-clockwise direction. Okay. So now we have, say, here is the child A, child B, child C, child D, and child D. So A is following B, right? A is always seeing B. B is seeing D. C is seeing B is seeing C, C is seeing D, D is seeing E, and E is seeing A, right? Again, the same problem happens. They had this arrangement initially, but now the kids tell, okay, we are so tired, okay, of seeing A seeing only B, B seeing only C. Well, we want to rearrange our seats, okay? However, there is one constraint. We do not want to sit, okay, or do not want to have the same person in front of us. How many ways can I do that? Looks very similar. These two problems are similar, but there is one problem. This one is more of a linear arrangement, right? There was no circle. Here it is circle, right? E is following A is following B, B is following C, C is following D, D is following E is following A. Here that A and E are at the end of the line. They do not have any kind of constraint. Here, no, everybody is following each other, okay? And yet they do not want to follow. They want to see how many ways they can arrange among themselves so that they will not follow the original configuration, whatever I showed you here. Now, I want you to think and tell me how will you solve the problem number 1 and then the problem number 2. Problem number 2 is a little bit more difficult than problem number 1, but if you understood the derangement problem, okay, you would be able to tackle it, okay? And even before you solve the problem, one thing I keep on asking you, you have to ask yourself, what is the catch? Okay, I want this to be, get into your head. What is the catch? Catch means why is it so tough? I just now talked about derangement thing, okay? And we talked about formula, right? Now, you know the derangement formula by this time, but I can assure you that formula would do nothing, okay, unless you've understood why the derangement formula works. If you just remember the formula and I give you this question, I can guarantee none of you will get the right answer. Though it is a derangement problem again, but you cannot directly substitute the formula as it is. And can somebody tell me why this is a difficult problem? Have all of you got the problem?
Yeah.
Yeah.
So I, first of all, even before solving the problem, help me understand what is the catch in the problem. Why is it different from the postman problem that we talked about? Though it looks very similar. There also did not want to send the, the letters to their own house. They are telling we do not want to follow the person whom we are following in our initial configuration. So it looks like a derangement problem, and yet it is very difficult problem. Why is it so?
Well, like one thing is that like if you want to fixate certain things, like we could fixate E and then rearrange the other 4.
But
to
there's
find-
also a possibility where you have where D ends up in the slot right in front of E.
Exactly.
So
then-
that's
You try to fixate the E and D, then all of those possibilities don't work because E doesn't want to follow D anymore.
So yeah, means that's a good idea. Okay, has everybody got the problem? No.
Yeah.
Yeah.
I got it.
Good. Very good. Okay. Very good. So the question now I have is, how are you going to tackle the problem? And I am ready to give you now maybe this 3 days, okay, where you can think about the problem, and that's good actually. Okay, forget about derangement or whatever you have learned so far. Okay, go to the foundation. Foundation means start writing. Okay, so I'm telling about 5. Okay, what would be the problem if I give you only 3? Can somebody tell me what would be the answer if I give you 3 or 2? Say what will happen if I give you 2? If I give you 2,
There's one way. One way.
and what is that?
Yeah, there's only one way, like
One
from
way.
A to B.
Yeah.
Okay, what would be 3? For 3,
3.
Is it 2?
what are they?
BAC and ACB. Going to the left, by the way.
Okay, B, A, C.
Yeah, so like that you can write as well.
And then B, C.
CA.
Good. Anything else? Anybody has any other idea? Looks like something is happening, but then the question is that the way I did that last time, right? What did I do? I wrote all the configurations, right? And then I started eliminating and adding, right? That's the pi principle.
Yeah.
Can you do a similar kind of exercise and then find out what is going on here? Okay, and then so then if we try to do that, okay, what is the challenge? I will tell you the challenge. Okay, the first challenge that you will face in any problem we call as encoding challenge, and this is a strategy that we have to develop. Okay, it comes through experience. Encoding is a problem in computer, in the world that we work in IT, right? Okay, it's a classic problem. All of us goes through the problem some way or the other. Those who work in machine learning, you hear that machine learning, they have a huge problem with this encoding. Okay, encoding is a way, okay, of representing anything in the world in a mathematical way. Okay, I'll help you, because this is something, if you develop, you become a good engineer, good scientist, okay, or a good mathematician. I will tell you what the problem states. Think of it. If I ask you, and I'll hear it out very clearly. Okay, this is helpful even for other areas of science. Okay, if I ask you to represent the weekdays, okay, weekdays, what are the weekdays you have?
Monday, Tuesday, Wednesday, Thursday,
Okay,
Friday.
Monday, Tuesday, Wednesday, and then after Sunday, what happens? Monday comes back, right?
It
Like
repeats,
a
yeah.
cycle. It's moving in a cycle, right? So if I ask you to represent Monday, Tuesday, and Wednesday, and all these, okay, till our Sunday, okay, mathematically, what will you do? You can give your ideas, and will tell you, okay, what is the problem? What can it do?
A, B, C, D, E, F.
Mathematically, I do not want
G.
ABCD. I want numbers.
Wait, so like
1
what do
to
you
7. 1 to 7.
4, 5, 6, 7?
Hmm?
Like what do you mean
1
mathematics?
1 to 7.
1 to 7. So
Yeah.
whom will I give 1?
Monday. I mean no, Sunday.
Huh? What is that?
Well, Sunday's the first day of the week.
Wait, so uncle, is it how many, like, well, you don't, it depends on where you start. That's the
Doesn't
problem with
matter
this.
where.
So
That's
is
the
that a
problem with this.
problem? Is that a
That's the
problem?
problem with
Yes, just
that's
now
the
we
problem
said
with
it's
the
a problem.
circle, right, Uncle? The circle doesn't have a start or the end, whereas a line
Very
does.
good. So circle does not have a start. So where do you start is depend on your discretion, right? So Smaran might tell, okay, fine, I want to start on Sunday. And then Manu, you are telling that I'll start on Monday. Okay. So that means you would change your convention, right? And then Smaran tells, Manu, I do not like this starting with 1. Okay, let me start with 0. Sunday would be 0, 1, 2 through 6. Okay. Manu tells, no. I will also start with Sunday, but not with 0. I will start with 1.
Does this matter, Uncle?
Hmm?
Does this matter?
Absolutely, it matters, right? So we have to represent mathematics, okay, every single thing in the universe, okay, in such a way that it's uniquely represented. Okay, then it's a big problem for mathematicians or anything. And here is the encoding comes into play. Those who are good in encoding, they would encode in such a way. Encode means this number that you are giving, that's an encoding, right? You are giving a number to a weekday. So now the question is that what can you do to ensure that they're unique, and not only unique, okay, we can also understand, okay, how the other days of the week are aligned to that particular day. For example, I would also like to know that Monday, okay, comes before Tuesday and after Tuesday, Wednesday comes, okay, some way by looking at the encoding itself. Now that's a difficult problem. So now we ask ourselves, in this set of weekdays, how many elements are there? What is the cardinality of the weekdays?
7.
7.
7. So first of all, I'll create a 7 things, okay, out there. Okay. I give 7 zeros placed side by side. Now, whenever, okay, you have day, okay, I'll put it as no. So that this is up to you. So somebody might have a common convention, but here is the deal, right? Say my convention is that we start with Sunday. That means we are essentially telling Sunday is nothing but 1, okay, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7. Monday is 0, 1, 0, 0, 0, 0, 0. See what is happening. It tells, if I just give you this encoding, okay, you understand just by looking into it, okay, and if I know the starting convention, that's a problem, initial convention, okay, that problem is still not solved, okay, but as long as I have a common parameter, few things are very much eligible, right? I know that I'm in the second spot, okay, I know how many spots are needed, okay, right? And accordingly, I can understand from the position of 1, okay, which day of the week it is. So this 0, 1, 0, 0 representation is an idea of encoding. I'm not getting into the bottom of it, whether it's the right way or the wrong way. In mathematics, this is important later on as you go in higher classes in 11th, 12th standard. If you would study mathematics, you'd be introduced something called vector, okay? So you will see that, there you'll be learning things like this, if at all, okay? However, undergraduate also they teach. But the important part that you have to understand is that this is a nice way of encoding a weekday. This is one of the ways of doing it, okay? Similarly, if it's a boy or the girl, right? We can always go with, no, boy or the girl is not the right example. Let me put it like this, okay? I have 3 pets, right? So if I say I have a cat, a dog, maybe a fish, okay? So I want to understand, okay, which family has which one. So you can tell some family has cat, some family has dog, some family has cat and dog both, some has fish, and someone has none. Okay. Again, encoding of this information that you have, okay, this information can be retained by representing them like this. If somebody is telling 0, 0, 0, you understand, as long as you know the order of in which the pets should appear, position number 1 is always for cat, position number dog is for and position number 3 is for fish. Then 0, 0 means this particular family has no cats, dogs, or fish, but no pets, right? If somebody tells 1, okay, 0, 1, then they have dog, cat, and fish, but no dog. You're
This is
getting
just binary, right, Uncle?
It's binary, right? So binary is a very effective way of representing things, okay? Right? So similarly, when we're talking about this, okay, remember the one that we're doing here, this is also an encoding. Do you all understand? This is a nice way. What was an quite is an encoding? In any element, you knew I had always a convention, right? The first one was reserved for house number 1. Second one was reserved for house number 2. Third one was reserved for number 3, and this one for number 4. So you always knew that it would be 1, 2, 3, and 4, right? and in that order. So there was some convention there, and therefore whenever you're looking at this number 2, 1, 3, 4, you immediately understood that here the second letter has got to house number 1, first letter has gone to house number 2, third letter has gone to house number 3, and fourth one has got to house number 4. Okay, you knew this just by looking at the numbers, isn't it? So we can tell this is the encoding. It helped us in cracking the problem, right? Do you agree this set is encoding? Now the question is that, okay, go ahead, sorry.
Oh no, I was just
Okay, so now the question is that the first thing that you have to ask in any mathematical problem, is there a way we can encode this problem? Because if we can encode, half of the problem is solved. If you have a nice encoding, okay, which can help us in getting into the meat of the problem, we have solved the problem. But what is the encoding? Is this a nice encoding if somebody tells A, B, C, D, E? Yes, might be, because you're telling, hey, infer it, right? A, B, C, D, E. But then how will you, define A, B, C?
Uncle,
Yeah, tell me.
can you do it in binary? Like if a camel is in its place, you put a 1. If it isn't, you put a 0.
But then also remember what is not happening is that when you're talking of 4 houses, right? There was nothing like house 1 following house number 2.
Oh, right. There's no order.
Order, but here the order is becoming important. Then if order is becoming important, okay, how do you encode it? Okay, see, one of the nice ways you can do it is that, okay, you can think it like this. House A, or how not house A, let's put this A as 1, okay, 2, 3, 4, and 5. These are the camels that you have. I'm telling this like this: 1, 2, 2, 3, 3, 4, 4, 5, right? 5. I'm telling this is nothing but representing 2 following 1, 3 following 2, 4 following 3, 5 following 4. Okay, this is different than
Oh, 1, 2, 3, 4.
what does this encoding tells you.
2 is following 1, 4 is following 2, 5 is
Correct.
following 4, 3 is
So
following
only
5.
one catch is there, right? These two should be same. These two should be same. Because if it's not same, then we have a problem, right? They have to be same, right? This right hand side, because 5 should be following 5 itself. It's like, no, I am following myself, right? That means because I am the one, right? So this 2 has to be same. So one way of encoding this is that 1, 2, okay, this is one element, 2, 4, second element, 4, 5, third element, 5, 3, another element. Effectively, we are telling that 2 is following 1, 4 is following 2, 5 is following 4, and 3 is following 5. But I do this with the extra bracket, okay? I give you, okay, very nice encoding. Now the question is stating that, okay, fine, how many such kind of following should happen? So you can think of it, this as one element. This is a 4 element. So how many ways you can do a different kind of followings? Is it 5 factorial or 4 factorial?
4 factorial?
And why is 4 factorial?
Because there are 4 orderings, even though there are 5 numbers. Like 4 pairs.
If I tell you there is no constraint on the problem, okay, what would be your answer?
5 factorial?
But now you're telling 4 factorial. So what is the right way of doing it?
Starting with 5 factorial.
Okay, if it's 5 factorial, then what will happen next? And what will happen if it's 4 factorial?
Meaning, uncle?
I'm telling you, what's the why should I go with 5 factorial, 4 factorial? See, I'm asking you to break it. If you do 5 factorial, think of it, okay? What can happen? Again, let's and I will not give you the full answer today, okay? But I am helping you to think, okay? If you follow this convention, okay, think of it. You all got what I'm trying to do, right?
Um,
It's a nice puzzle. Please do not.
I don't really understand like what you're doing here with the coordinates.
You do not understand that?
No, not really. Like I understand.
I understand what you're doing, Uncle, but I don't understand why you're doing it.
Yeah.
That's, see, somehow you have to bring the following into play, right? That
Right,
when a
right.
camel is following somebody, okay, that's a concept I introduced in this problem, isn't it?
Right.
Yeah.
So somehow that following part, you have to bring it into a set, okay, or a symbol, okay? And you do not have a good way of doing that. That means you have to tell that, okay, when I'm telling follow, right? Is it between following among 3 people or 2 elements? How many elements would be how many elements do you need to introduce the concept of following? If I tell you that's
2,
2, right?
Yeah, 2 or more.
2, right? Exactly. So if I ask you right now, tell me, okay, how many people should be involved, okay, to introduce a concept of pairwise friend, okay? You tell 2 people are needed, right? Very simple. That means those 2 people are mapped to each other, right? Similarly, when I'm telling following concept, I need 2 elements. So therefore, to encode it, okay, I introduce this concept. Otherwise, what will happen? You can always say, uncle, I will not go for this. I'll go 1, 2, 3, 4, 5. See, no harm in that. But here, I'm still not understanding who is following whom.
Oh, I see what you're doing now, Uncle. Like there's no like way to really understand.
Understand the concept of follow, right? That is not coming into play. So that's why I deliberately introduced this way. But now the question is that if I tell you how many different ways can they arrange among themselves, one of your instinct could be, let's do by this convention as 4 factorial. But I'm telling that, no, that's a bad idea. Can somebody tell me why it's a bad idea to do 4 factorial?
Because 5 doesn't have anything following it, Uncle.
No, that's not the question. If we do like this, then one of the arrangements be like this?
Oh, yeah, where the pairs don't arrange properly.
Here, this is the absurd concept, right? You are on one hand telling 2 is following 1, and then 4 is following 3. That is not possible, right? I told you these 2 have to be same. These 2 has to be same. Is it same here? Are you not getting, right? Think of it. Think this 2, 1, okay, that's one element, okay? Then you have 3, 2 is second element. 4, 3 is third element, and 5, 4 is another element, right? That's fine, because 2 is following 1, 3 is following 2, 4 is following 3, and 5 is following 4. Good. Now, if I tell that let's arrange these elements, okay? So let's say 2, 1 came here, 3, 2 went here, 4, 3 came here, and 5, 4 came here. So this could be one of the arrangements, right? Where position number 1 is now 5, 4. Position number 1 is 5.4. Position number 2 is 4, 3. Position number 4, 3. 3, 2 has gone to this position, while 2, 1 has come to this position. But here is the problem. If you look at the whole thing, then this is the absurd thing happening now. Why is the absurd thing? Because now you are telling, by this convention, 3 is following 2. Very good, no problem. Now, all of a sudden, you're telling 2 is following 1. That is cannot happen. If 3, 2, this has to be 3, right? You cannot make it 1. How can it be 1? Then the entire convention is completely falling apart. You do not want that to happen.
Uncle, I thought we were looking for how many ways they're not following each other, though.
No, that's not what I'm telling. That's not even the problem. Problem is that does this whole symbol make any sense? 5, 4, 4, 3, 2, 1, 3, 2. If I ask you that, tell in plain English, what does this symbol tell you? What will you tell now? You will tell 3, 3 follows 2. Right? Then you're telling 2 follows 1. If 3 follows 2, then 2 has to follow 3 only, right? This has to be 3. There is nothing called 2, 1. It cannot be.
Oh, it doesn't even exist, right? In that.
Exactly. So
Oh, I see.
this could have been a good one, right? Good permutation for you. 4, 3. because now 3 and 3 are matching, right? And that would enforce that if this is 4, then it has to be 5, 4, right? And then finally again you have a problem because
2, 1 can go in the
cannot be,
end.
because there's 1 and 5 are not matching. So you understand, right? There is a problem, okay, in your definition, then your configuration is not matching. So now
Yeah.
the question is that how do you solve this puzzle, right? I'm just wanted to show you, okay, that you can use some convention, but then the convention can fall apart, okay? So I would like you to think about the problem, these 2 problems that I stated, okay, and put that in the canvas, okay, and come up, okay, with some ideas. And ideas are good, okay? It might not be the best idea, it might not help you, but it will help you to think, and more you think, you better become a better mathematician. It cannot be given to you in a plate. If I give you the formula, if I solve the problem, yes, you will understand the problem, but then I give you another problem, again you will fail. But I can tell you one thing, you can use this convention that I just now told you to your advantage, because this gives you the follow convention, and it is also a derangement problem. I can tell you that also. Whatever concept you learned from in the hard way, right, by putting, if you use this convention and start writing all the possible things and start eliminating, giving back using the pi principle, I will tell you, you'll get the right answer. I would like you to work by hand in a very tabulated way. Tabulated way means manually, okay? Write out what are the possible things that can happen, what are the things I should subtract, what are the things I should give back, okay? And get some answer. You learn the hard way. It might take a couple of hours, that's fine. But what you learn will stay with you. Then any problem given to you, you can solve it. And if you just start doing, okay, forget about it, I'll not try. What I'll do is that let uncle give it in the next week. Okay, anyway, uncle will tell it, okay? So let's not try anything, okay? Forget about it. That's fine, but remember, okay, next time another problem is given to you, you will again fail, because you are not trying. So you have to understand, okay? And how do you understand? By going the hard way. Let it take a couple of hours, but I want you to try it. It's like a puzzle, okay? Do not take it as mathematics, okay? Take it as a puzzle, try it, and let's see how it goes. Are you all good?
So, do you want us to like try to solve this?
I want you to solve this. Not
Okay.
now, at home, okay? So take this problem. You've understood the problem, right? Both problems. One is the merry-go-round circular problem. Another is linear problem. I want you to give a try, okay, before I give you the solution.
Uncle, for the merry-go-round question, it's also 5 entities, right? 5 kids.
With 5 entities, but I'll tell you one thing, okay? My idea is not with 5. I want you to solve this problem for n number of camels and n number of kids in the merry-go-round.
Right, okay.
That is
So
my ultimate goal.
you want us to find an algorithm almost?
An algorithm, exactly. I want all of you, okay, to have an idea of algorithm, okay? I do not treat mathematics, okay, as some kind of numbers. For me, this is a computer problem. I work in that world. For me, everything is algorithm. And
You
that's
also have to find an algorithm for the camel question where there's no
yes,
like.
yes.
Okay.
Camel question also, you can start 4 or 5, but ultimately your objective is that forget about 5. If somebody gives you n number of camels, and n can be anything, it could be 100 camels or 2000 camels, okay? Your algorithm, okay, would know if I put it in computer, it will come back, okay? Using that algorithm that you have developed, we can write a short program together and not back the value. In fact, okay, that's what I would be teaching you. Ultimately, we'll take this class not as mathematics class. We'll be writing programs, okay? So that we feed the value of n, immediately the program would give you, based on the algorithm that you develop, okay, give the value, okay, how many ways you can arrange. And that's the perfect way of learning. Mathematics and computing should come together. It cannot go, one going in one way, other going the other. Computing an algorithm, okay, is very much tied to mathematics, okay? That's because we always are developing the algorithm. It's not just plugging some formula. No, that's not mathematics. That's not computing. Our idea is that we develop an algorithm, and in computing, what we do is that Even if you're an algorithm, we cannot do repetitive process, right? If we have to do 100 times, that is too laborious. So what we do is that we write a short program, but the algorithm is what matters, right? Even in computer world, those who have finest of algorithm, okay, write the finest of algorithm, they're all good mathematicians. They all good computer scientists are great mathematicians, right? And I want you to develop that idea, right? That don't treat them, oh, computer programming is different from mathematics. No, it's the algorithm that matters, okay? This syntax means whatever, write in Python, Java, or whatever language you are learning. Those are the easy part, okay? Those anybody can do, okay? It doesn't take so much of time. But the algorithm part, that requires a lot of time. That's not easy at all. That requires rigorous practice, okay? Because that's completely brain power. But if you can have the algorithm, then writing it in a program that we can do anytime. Even the one that we're doing with this, the derangement problem, at some point I'll show you, okay? We can write a program in no time. It's a very easy program to write. But the algorithm I'll be using the same thing, okay? That way, right? NC0, right? And then NC1, 1 factorial, and plus and minus together, okay? And then we'll be writing a for loop, okay, in a Python program or Java program, and it should be done in no time. You've got it, what we're trying to achieve here?
Yeah, Uncle, I have a question at the end.
Yep. No, I'm done. I'm done. If you have any questions, throw it, okay? That's all I expect from you. And if you have no question, you can drop. Okay, go ahead. Whoever has the question, raise your hand and you can go ahead.
So, Uncle, it's Manu. I was just like, I didn't still understand like for the derangement, Uncle, the one in the four choose like the 4 factorial in the beginning. That's how many ways everything can rearrange themselves if you don't choose anything, right, Uncle? But at the one at the end is like how many ways everything gets the right letter, right? So why don't we include that as well?
Okay, so let me tell you the question another way, okay, so that you understand this.
Okay.
If I ask you A union B union C, right? Sorry, A union B union C means A or B or C. This is how you do it, right? A plus B plus C, right?
Yeah.
Minus A intersection B minus B intersection C minus C intersection A minus
Plus,
section
sorry.
C, and continue. How many would be there? Yeah.
Um, is it not wait.
Uncle, is C intersection A not the same thing as A intersection C?
Maybe I made a mistake.
Yeah, it's 3 choose 2, right? So 3.
Yeah.
Okay. This is 3 choose 1. Okay. Not 3. It should be 6. Why do I do it? Okay. Out of 3. Okay. I give 3, right? My bad. My bad. I wanted to keep actually 4. So let's start with this. How many would be there? First we understood 4. Okay. So how many pairwise you will have?
4.
4.
Or sorry, only 2, right? So 6.
And how did you get the 6?
4 choose 2.
Okay. Now we'll have pair. All of you understand this, right? Whoever is left behind. 4 choose 2, because out of these 4, any 2 of them can form a pair, right? And we can hook them up.
Yeah.
Right.
Now, how many ways you will go with A intersection B intersection C, and how many ways you can do it?
4.
And how did you get?
4 choose 3.
Then what do you do?
4 choose. Well, don't you subtract the A plus B plus C?
No, absolutely. So what is that? How many ways you can do it?
1.
1. So your question now drops down to that: why are not adding this 1 in your pi principle? Is it the question?
Yeah, at the end.
Okay.
Yeah.
Now that question will be answered. Think of it. when you have 3 letters, okay, being delivered to 3 means 1 minus the total number of houses that you have. If those 3 houses are fixed, can you tell what is happening with the 4th house?
There's only one way.
That means, can I tell if the 3 houses are fixed, the 4th is also fixed?
Yeah.
That means, is it a new information for you?
No.
If it's no information, then what's the point in adding or subtracting, because they've already got to the end, right?
But uncle, if the 3 are fixed, uncle, and like how do I say this? If the 3 are fixed, yeah, the 4th one is also fixed, but um like
No, tell. I want to hear from you. I know I always like, okay, whenever anyone challenges, okay, I want to understand, okay, what's going on. That's the most.
it's not, but it doesn't include like the way everything gets the right letter, right? It's only, I mean, it's fixed, uncle, but there's also um like the first 3 houses have to rearrange themselves, right? But we're not talking about
First 2 houses have to.
or
And
first 3 houses have to rearrange themselves, right, uncle?
first 3 houses never rearrange. Do you recall?
Or
Okay,
sorry, you're choosing the first 2 houses and the
first 3
last one.
houses. That means there is only 1 house left, right? And that's the only one. What can now 1 house can rearrange among themselves in 1 factorial ways.
Right.
So if that is done, then
So-
what?
yeah.
I'm sorry. Go ahead.
This goes back to the first problem with the 4 houses, right?
This is repeat it once again.
This is basically the problem with the 4 houses, right?
That's correct. Correct.
Yeah, so I think when we were trying to find possible way without restrictions, when we were finding possible ways 1 and 2 paired together, and there was that the first set which 1, 2, 3, 4, and I think we were already accounting for that in the possibilities. So I think, is that why we don't add it at the end as well?
But
Mm,
the first one, uncle, is how many ways everything can rearrange themselves if you don't choose anything. The one at the end is how many ways can you select, or how many ways can you choose out of, or how many ways can you choose 4 from 4?
so what is the general idea you are thinking?
But isn't not changing anything and just keeping everything the same thing?
Good job. Good job, kids. Okay, I wanted to see how long you will know get it. Okay, good job. So what do you think? What do you think? Should that 1 be there or not there?
Um,
What is Manu telling? What is Maran telling?
well,
Like,
I'm saying it
it's
should
hard
be
to
there.
know.
Okay,
Manu-
hold on. Manu is telling it should be there. What is Maran telling?
He's arguing it shouldn't.
Shouldn't. And what is Maran's argument?
Well, I don't know. I was thinking that the 4 choose 0 is basically the same thing as the 4 choose 4, because it's basically
No.
not changing anything.
That is observations, Maran. But the question is that if whenever developing an algorithm, okay, we need a logic. Okay, why should be that? Don't go by the pattern. Okay. So
Yeah.
you question to the last minute that, okay, fine, is it worthwhile to continue or should I stop the whole thing? Okay, let's ask this question. Okay, and I'm not telling yes or no, because I've told Manu, okay, but let me tell you to the whole group, okay, who are here. I'm notorious in one thing, okay, and this I generally do things, okay, the way a little bit different than whatever you have seen in classroom. Okay, I would do some deliberate mistakes while talking with you. Okay, and I want you to find it out. I want you to challenge me, telling, uncle, this is wrong. Okay,
Yeah, I didn't agree with the statement, uncle.
so you are hatching to that should be 1, right?
Yeah, I think you have to add You
Okay.
have to
Why don't
calculate
we
the
do this
other thing.
exercise, okay, together, okay? I'm still not telling Manu is correct or Smaran is correct or I am correct. Means Smaran is agreeing with me to an extent.
Uncle, I also what's it called? I manually calculated what
And you got that extra one.
yeah, you have to add the one at the
Yeah.
end, Uncle. Because
Okay,
otherwise you'll have
then
8.
I'm already you already have got it right.
It's
Okay,
faulty
thank you.
logic, yeah.
Okay,
Yeah.
you need the one. You need the one. You need the one. Okay, I wanted to see. Okay, I would have revealed it.
Yeah, I didn't want to be like rude or anything, Uncle. That's why I like even messaged Smart. I was like, I don't know if I should like ask or anything about it
See,
either.
I want you to test. Okay, and that's how. Okay, that's how last day also. Okay, how did I tell you that you have not understood the full thing? Because none of you challenged me. Today also I would have let you go because I wanted to think. Maybe I thought that somebody would come back. Okay, in the next iteration, next class, and challenge me. But I was waiting for this time. But Manu anyway challenged me, so that's good. I love it. Okay, yes, that one is indeed needed because the reason is that. So what? You have gone to the 3. Okay, you have to still
They're
have
different.
all houses. Want to select all houses, and then the question is that what happens to 0 factorial? I think Smaran told, right, 0 factorial is 0 or something. Answer is no.
0 factorial is 1.
0
One.
factorial is 1. Okay, and I will now tell you something very fantastic. Okay, which those of you are here, okay, they might be hearing it. 0 factorial and 1 factorial are both 1. There is a fantastic argument for it, okay, which I would have told next time, but now that we're talking anyway, let's see, okay, how we can argue with somebody. This is generally not being shown in books. I do not know why, but this is my kind of idea, okay, which I will have.
Could I explain my
Yeah,
like
go ahead.
philosophy, Uncle?
Please,
So how many ways can you rearrange one object is one way, just there, and how many ways can you rearrange 0 objects is also one way because you're inherently doing nothing, which is doing something, which is
Yeah.
one way.
That's good way. I'll tell you another way, okay, and that's a very good argument, okay. But I'll tell you another way. Can you tell me how many ways can you arrange n people in a line? N people. N people means 3 and the nth people. How many ways can you arrange them?
N factorial.
N factorial. Very good. How many ways can you arrange n number of people in a circle?
N minus 1 factorial.
Who told that?
Pranad.
Pradhan,
Yeah,
how did you
I
get it?
agree.
That's correct.
Because like in a circle, there isn't like a designated starting point.
Order.
Yeah, so it's one way of looking into it, right? So one way of looking into this we can fix one of the person, okay, and think it like a necklace and cut this one.
But then
you're
you're minusing
then it becomes a
1.
linear problem, right? You think it like a necklace or like a rope, okay, which has been cut open, right? Now it's no longer a circle, it's now a n minus 1 people in a line, right? Any one person you can take it, then you can think of it as lying up, so it will be n minus 1 factorial. It makes sense, right? If there are 2 persons, okay, sorry, 3 persons, say A, B, and C, okay, you will have only 2 ways, right? Either have A, B, and C, or A, B, and C, because this one is clockwise, this one is anti-clockwise. That's all you can do. I fix A, okay, or fix C, okay. So now the question is that if there's one person, how many ways can you arrange one person in a line? From your common sense, how many ways can you arrange one person in a line? Only one way, right? And your formula is also telling that, right? So 1 factorial must be equal to 1. Do you agree?
Yeah.
If I tell how many ways can you arrange one person in a circle, by your formula, what should happen?
It should be
1
zero.
or
1
way.
minus 1, 0 factorial, right?
Yeah.
Yeah, but
What is the common sense telling?
1 way. You can like still rearrange it 1 way by
Is
just
0
keeping it
factorial
there.
equal to 1?
Yeah.
Yeah.
This is something, this is something you have to understand, okay, that we have a subtle ways, okay, in mathematics. Sometimes it's not obvious. If you go by the formula, and that's why I do not like the formula, okay, formula tells that n factorial is n times n minus 1, n minus 2, like this, okay. Then you will tell, okay, fine, 0 factorial must be equal to 0, and because we are not going in the negative, so it's 0. So no, that's not what the formula is telling. There is something else involved in the formula which you do not understand. N factorial is telling n times n minus 1 till 1, okay. However, the formula does not tell us, okay, what will happen when n is equal to 0 itself. It does not tell anything about that. But we understand 0 factorial is also equal to 1. Yeah, you're getting the point, right? And
Yeah, I think I get it now.
yeah, and that's the reason, okay, why we should not end with that n minus 1th house, okay? We should go to the next iteration and finish up, okay? And let me do it in the right way. I was about to do that. Here, when you are doing it, where is that gone now? Yeah, I went till this, okay? And then you'd, sorry, yeah, the final one, whatever I was doing. Yeah, here, it does not end there, okay? It should be plus 4c4, no, 0 factorial. That means it would be either plus 1 or minus 1, depending on whether it is odd number or even number. Do you all agree? If it is 4, okay, we are seeing the plus. If it had been 5, then the last one would be minus 1. Do all of you agree? It would be plus minus,
Right.
minus, right? Then
Or
last one
4.
would be negative 1, right? Minus 1.
Yeah.
If it is even number, okay, n is equal to even, then it will be plus 1 at the end, okay? But the series will continue till the last one, which is 4c4 times 0 factorial.
Yeah, and also they represent different things, Uncle. That's why you have to include the
That's why,
plus 1.
yes,
But then
absolutely.
that's what I was trying to explain.
Absolutely correct. So no, absolutely correct. And I love this. Okay, Mano, I'll tell you. Okay, I loved it. Okay, the way you know stayed on and told that. Okay, fine. I completely disagree, and that's what we want in the circle. This is a math circle for that reason only. I want myself or yourself to be challenged. Okay.
Right.
Good that you caught it. Okay, I wanted to see that. Another thing I am also observing that, okay, at least Manu did it, and I expect all of you to do it. Do the manual counting. Tell why is it not matching? Question yourself, okay? Otherwise, you not learn maths. Otherwise, teacher would be talking. You just listen to the teacher blindly and agree to whatever the teacher is telling or the coach is telling, okay? That's not the right way of doing mathematics. Mathematics becomes fantastic once you challenge your teacher or coach. Okay. Good.
Okay. Thank you, Uncle.
Fantastic. Lovely. Okay, but those 2 questions are your assignments. I'll put that into the canvas together with some other questions. Okay, please try to attempt them. Okay. Good. Any other question anybody has? No?
Yeah, Uncle. Could you extend?
One survey I want to take. We're all 6 of you are staying, okay? I want to go through the entire group of people. Let's see, okay, what they're still. Okay. I can.
Uncle, also when the class is over, can you extend the deadlines?
I extended for one. You extend for everything? I can do that.
No, I just didn't know which one, Uncle, did you extend for?
There's a basic.
AMC combinatorics. Yeah, found it. Okay.
So let me take a quick vote, okay? So Manu, what is the understanding from today's class? Is it near to 100%?
Yeah, Uncle. At least everything we talked about until this new problem, I have to look at that, but everything else I understand fully.
Okay, good, fantastic. How about Smaran?
I think the derangement, like I was following along. I wouldn't say fully 100%, but yeah, I following good enough, yeah. And then with the new problems, I'll also have to look at that.
Okay, let's move to Pranad.
I mostly understood like everything in the derangement. It was kind of just like finding like an understanding to do the camel problem because there's like certain restrictions that are different for the other ones.
Okay, but you think you're in a position to attack the problem?
Yeah.
See, that's what I wanted to hear. It's not about always problem solving. Okay, solving is a different aspect. That a little bit luck is needed, little bit of strategy is needed. But attacking is all about courage, right? I might not want to go to Mount Everest and climb it. Okay, that's fine with me. But at least I should be in a position telling if I'm really an adventurous guy. Okay, I want to attack the problem. I'm not coward, right? I'm not going backtrack. Okay. That's important. Okay, that's a step number 1. Now, whether it be successful or not, that we do not know, right? But at least you're attacking. Very good, wonderful. Arjun?
So like, well, as you were like dearranging like deranging everything, like I followed along pretty well, and I thought it wasn't too hard, but like I didn't understand the whole thing fully, 100%. But
So what are you going to do? Are you doing the canvas things? Whatever I'm giving. Have you?
I don't think I'm in it.
I added you
You did?
a long back.
Okay, I'll talk to my mom about it because
Yeah,
I was
just
never
check.
aware of it.
I added you. Okay.
All right.
Then we have Neha.
I understood the derangement pretty well, and I have like a 70% understanding what we just.
So what are you going to do with the other 25% that is not there?
I'll find other ways to do it and like watch some videos too.
Yeah. So see, watching the videos is all welcome. Okay, you do whatever, watch videos, search in internet. I do not mind. Okay, but mathematics is one thing I can tell you. It's not about watching or hearing. Okay, you have to try it yourself. Just like the way I want everybody to learn from what Manu did today. Okay, and this is something I do. I almost do every day, unknown to you. Okay, every day I have at least one thing I tell wrong deliberately in the middle of the class. Okay, because only reason I do it is that I want you to think that why is it happening? Okay, so today that was the one, but Manu found out. Okay, and every single day I've done one mistake. Okay, deliberate mistake, so that now you can catch me. Okay, and the next day, but I do not see anybody challenging me, and that's why I told that. Okay, I do not like it when I don't think you learned it the whole thing. Okay, and nobody challenged me. So how do you challenge yourself? Go through the whole thing. I shared the recording. Okay, go through a recording if needed. Go do some internet, YouTube, do whatever is needed. But then come back and tell that, okay, fine, no, this is the part we are not understanding, or uncle, that's the part which you told wrong. Then I'd be happy. Then I'd be fine. Yeah, I told wrong. Look at this. This kid found out. They're really hearing each and every word of mine. If that does not happen, then this is not a it's a futile exercise, right? And this is not for Neha. I'm telling the whole group. Okay.
Yeah.
Thank you. Good night. Okay, we'll talk again on Sunday. Bye.
Okay. Thank you, Uncle.
Thanks, Uncle.